Everyone, welcome to this session wherein this is a derivative problem, and we need to find out two parameters in this particular problem. And before proceeding, we need to represent or we need to interpret the diagram by going through the statement of the problem. After that, the solution can be derived. So statement goes like this: it is a three-hinged parabolic arch of span L and rise R. So we need to draw first a three-hinged arch, and the span of that particular arch is L. Span of the arch is L means the distance between the support is L. We need to mark point A, point B, and the distance between both the support is L. The central rise is R. That means the height of the crown from the center line of this particular arch, rise is R. So this particular rise has been called as R. And it carries a uniformly distributed load of W per meter over the whole span. That means from left side till the right side, it carries only singular loading, and that particular singular loading is a UDL of W per meter. This is what is the magnitude of the load that it has been subjected to. And what we need to do is, so up till this particular point, all this particular statement is been represented in the form of the diagram. So diagram statement says it is a three-hinged parabolic arch. So this is also a three-hinged parabolic arch. Hinge has been placed at A, B and C. The span of the arch is L. That means the distance between A and B is L. And rise is R. That is this particular height or the location of point C is placed at a distance of R. Then it has been subjected to a load of W per meter over the whole span. So on the top fiber of this particular arch, it has been subjected to W per meter over the whole span. So what we need to do is, we need to find out horizontal thrust at each support. At each support means at A and B, there is a B and horizontal thrust. Horizontal thrust means HA and HB needs to be determined. HA and HB needs to be determined. Apart from that, we also need to ensure, or we will need to find out that at any distance mx, whether x will be 0, whether x will be 0 or x will be L, at any distance mx, moment value should come out to 0. This is what we need to calculate, or we need to derive the solution now. Now to begin with, since it is A is hinge, B is hinge and C is hinge, A will have two reaction component, B will have two reaction and C will have two reaction component. Now two reaction component that is available at C will be get nullified because AC is the left side section and BC is the right side section. AC is left side section and AC is left side section and BC is the right side section. So for AC, the reaction may be in the upward direction, whereas for BC, reaction will be in the downward direction. Likewise, for AC, reaction will be towards the left and right hand side, and here it will be left hand side. So net moment at or net force at C will be 0. So as a resultant, we will be left out with only reaction at A and B. So if we happen to represent the reaction at A and B, we need to show two reaction component at A and two reaction component at B. Since it is a hinge support, it will have a vertical reaction force component and horizontal reaction force component. Likewise, vertical reaction force component at B and horizontal reaction force component at B. So if we represent the force here, so this will be the reaction component which will be VA acting upward. Likewise, VB will be acting in the upward direction because UDL is downward direction. Now if we consider AC to be towards the left hand side and the UDL is been placed over the arch, A will try to move towards the left hand side. As a resultant, resisting force or the reaction force at A will be towards the right hand side. Why it will have a HA is because it is a hinge support which will have two reaction components. So HA will be towards the right hand side. Likewise, if we consider BC towards the right hand side section, if the load is been placed on the top fiber here, B will shift towards the right hand side and reaction will be applied towards the left hand side. And this reaction will be called as HB, which will be a resisting force not to allow the arch to shift towards the right hand side. So we need to find out the value of HA and HB. And the value of HA and HB should be WL square divided by 8R, where R, what has been mentioned here is rise of the arch. R has been mentioned as rise of the arch. R is nothing but the rise of the arch. That is what we need to derive now. Now to begin with the derivation, we shall find out the reaction component here. So we are going to make use of equations, three equations of equilibrium, that is summation fx0, summation fy0, and moment with respect to the support is equal to 0. Now support is equal to 0 means moment with respect to A is equal to 0, moment with respect to B is equal to 0, and moment with respect to C is equal to 0. To begin with the first step, that is summation of Fy is equal to 0. So all upward forces shall be considered as positive, all downward forces to be negative, all right hand side forces to be positive, and all left hand side forces to be negative. Likewise, all clockwise rotation will be positive and all anti-clockwise rotation shall be considered as negative. So following the same sign convention, we shall consider summation Fy is equal to 0. So VA and VB acting upward, so both will be represented as positive, VA plus VB. Now it has been subjected to a UDL which is in the downward direction, minus W into L is equal to 0. So VA plus VB is equal to WL. So equation number 1. So keep this equation as it is because we need to find out the value of VA and VB. Next we will apply summation Fx is equal to 0. To consider summation Fx is equal to 0, as stated, right hand side forces are positive and left hand side force is negative. Likewise, HA is oriented towards the right hand side, so it shall be considered as plus of HA. On the other hand, HB is oriented towards the left hand side, so minus of HB, that is equal to 0. So as a resultant, HA will be equals to HB, so equation number 2. So keep this particular equation as it is. Next we need to consider moment with respect to the support is equal to 0. So here we shall consider moment with respect to A is equal to 0. If we consider moment with respect to A is equal to 0, with reference to A, VB shall rotate in anti-clockwise direction. So if we consider A at this end and VB to be acting here, VB shall rotate the arch in anti-clockwise direction. So minus VB into L. Then with reference to A, UDL has been placed on the top, it shall rotate in clockwise direction, plus of W into L into L by 2, that is equal to 0. L by 2 is nothing but the CG of the load, L is total length of the load and magnitude of the load is W. So reframing this equation, VB into L will be equals to WL square by 2. So VB will be equals to WL by 2. So this is what is the first unknown that we have calculated is WL by 2. Substitute this in equation number 1. If we substitute in equation 1, VA will be equals to WL minus of VB, which will be WL minus of WL by 2. VA shall come out to WL by 2. So this is what is the second unknown that we have calculated. So VA value is calculated as WL by 2 and VB value is also calculated as WL by 2. So both the values are same because it is symmetrically loaded. As a resultant, both the magnitude shall be same. Now next task is to find out the value of HA and HB. So the value of HA and HB shall be calculated and computed in such a way that the value of the value of horizontal thrust should come out to WL square divided by 8R. That is what is the unknown or the problem in hand now. So to find out that, we shall draw this particular arch again. When we draw the arch, redraw this particular arch, HA shall be shown towards right hand side and this VA value is WL by 2 and VB value is WL by 2 and HB has been shown towards the left hand side. Point C is marked here and over this there is an UDL that has been placed. Now we shall find out the value of HA and HB. As stated earlier, we will be calculating moment with respect to the support. So when I say moment with respect to the support is provided at A, support is provided at B, support is provided at C. I have calculated the value of VB by considering moment with respect to A is equal to 0. I got the value of VB. If I happen to take moment with respect to B, in that situation, I will be getting the value of VA. But I have calculated both the values VA and VB. For that reason, moment with respect to B is not been calculated because already the unknown of VA is been computed. Now next task is to find out the moment with respect to C because C is the third hinge. C is the third hinge. So I shall consider moment with respect to C is equal to 0. When I consider moment with respect to C is equal to 0, there are two segments of the arch now. So A to C is left side, whereas B to C is right side of the arch. We can choose any portion of the arch. The solution of HA and HB shall come out same. So if I happen to consider left hand side part of the arch, so left hand side part of the arch will be A, C and UDL been placed here. And value of VA is WL by 2 and HA is placed towards the right hand side. So with reference to C, the distance of this particular arch is rise is R meter. So this is what is the value of R. Considering moment with respect to C, VA is acting upward and distance between A and C is L by 2. Distance between A and C is L by 2. So considering moment with respect to C, VA into L by 2, because VA with reference to C shall rotate in clockwise direction. Likewise with reference to C, HA is acting on towards the right hand side, which will rotate in anti-clockwise direction, minus of HA into R. For vertical force, horizontal distance will be multiplied as perpendicular distance. For horizontal force, vertical distance will be multiplied as a perpendicular distance. So this is equals to 0, because you are equating moment with respect to C is equal to 0. Now value of VA has been calculated now, which is WL by 2. And in addition to that, you also have UDL that has been placed on the top. With reference to C, UDL shall rotate in anti-clockwise direction. So minus of W into L by 2 into L by 4, and whole thing is equated to 0. So if we reframe this equation by considering HA towards the right hand side, HA into R. So if you consider moment with respect to C, VA shall rotate in clockwise direction plus VA into L by 2. With reference to C, HA shall rotate in anti-clockwise direction minus HA into R. Since we don't have a space, I'll be writing down below here. And UDL shall rotate in anti-clockwise direction minus W. Length of the load will be between A to C, because you are considering left side section. Left side section is AC. Distance between A to C is L by 2. So the magnitude of the load is W. Length of the load is L by 2. Center of the load will be L by 4. That is half of L by 2 will be L by 4. So if we reframe this and take this particular section HA into R on the right hand side, on the left hand side it will be VA into L by 2 minus of WL square by 8. To 4 to the 8. So substitute the value of VA as WL by 2 into L by 2 minus WL square by 8. On the left hand side you keep HA into R as it is. So resolving this, WL square by 4 minus of WL square by 8, which will result as 8 minus of 4 divided by 4 into 8 WL square, which will be in the numerator it will be 4 divided by 32 WL square, and then the left hand side will be HA into R. So HA value shall come out to 4 ones are 4 8s are. HA value shall come out to WL square divided by 8R. So this is the value of HA that has been to be derived now. So what has been asked is HA value, or the horizontal thrust value. Horizontal thrust value should be WL square by 8R. So that is what we have derived, the value of HA as WL square by 8R. So from equation 2, HA is equals to HB, which is equals to WL square by 8R. This itself is horizontal reaction at A and B. So this is what is the derivation that has been calculated. So this was what was required in the first statement now. Now we shall try out the second unknown parameter that is required. That is, moment at any distance x should be calculated as 0. Now for that, I shall redraw this particular arch again. Consider this particular value of VA as WL by 2 and HA value as WL square divided by 8R. And distance between A and C is R. And you are considering this particular UDL throughout the length now. Now for this particular case, I shall consider at any distance x now. So x shall be starting from the origin A shall be considered from the origin for the parabolic arch when it is symmetrical parabolic arch. So from A, if I consider at any distance x here now, so moment at x shall be written as VA into x, then which rotates in clockwise direction, plus minus of, as this is at any distance of x, so height at this particular junction will be called as y. So HA shall rotate in anti-clockwise direction. With reference to x, HA is towards the right hand side, which will rotate in anti-clockwise direction, minus of HA into y. Then on the top you have a UDL. So UDL we shall rotate in anti-clockwise direction, minus of W into x by 2. So we need to find out the value of m of x. Now m of x that we are going to find out is been mentioned that it should come out to 0. That is what is the requirement. We shall verify this particular value whether it shall come out to 0. So m at xx will be VA value is WL by 2 into x, minus of HA value is WL square by 8R into y value, the equation for parabola, and y value is y is equal to 4Rx divided by L square L minus of x. This derivation I had done in my previous session. So substitute the value of y as 4Rx divided by L square L minus of x. So that is the value of y that we are going to substitute, minus of W x square by 2. Now once we substitute this and reframe the equation, here we can find out that r in the denominator, r in the numerator gets cancels up, and L square in the denominator, L square in the numerator gets cancels up. So as a resultant, mxx equation shall be WL by 2 into x, and on the right hand side, first term when it goes and multiplied, this will be 4 ones are 4 twos are 4 in the numerator, 8 in the denominator, 4 ones are 4 twos are. So when it goes and multiplied in the inside, this will be first term W, x and L. So it should be minus W xl by 2. That is the first term. And minus into minus will become plus. Plus of W x square by 2, because denominator you already have 2 here. Then plus of W x square by 2. So as a resultant, if we observe WLX by 2, which is the first term here, WXL by 2, which will be W by 2 into X into L. So WXL by 2, both will get cancelled up. So positive and negative. Similarly, Wx square by 2, then plus minus W, because this value is minus here, minus Wx square by 2, both will get cancelled up. So net moment at x shall come out to 0. So mxx shall come out to 0. So this is what is the derivation that was required to find out. What was told here is to find out that horizontal thrust is WL square by 8R, that is what is calculated as HA and HB, and moment at x has been calculated as moment at x is equal to 0. So moment at x is computed as 0 as WLX by 2 first term, then WX into L divided by 2 second term, minus into minus will become plus, Wx into x will become x square, denominator 2 shall kept as it is, then the last term minus is kept as it is, and Wx square by 2 is been considered. So positive and negative will get considered, positive and negative will get cancelled. So net moment at any distance x shall be considered as 0. Whether you substitute as L or whether you substitute as x, net value anywhere along the section of the arch, moment value shall come out to 0. That is what is the significance of the parabolic arch. Anywhere along the length of the arch, the particular moment shall come out to 0 when it is a uniformly distributed load which has been spread throughout the entire span. Thank you. Have a nice day.